This is Foundational Mathematics for Secondary School Intermediate Level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log into our website from any place at any time and view past videos, practice problems, and solutions for your course. For more information on the services we offer, please visit www.limitlesslearningtt.com. If you have any additional questions or concerns, please feel free to email us at info@limitlesslearningtt.com. In this lesson, we will be introducing inverse functions. Now, in the previous lesson, we spoke about regular functions having a domain and a range. And our function would take us from our domain to our range. So if we had 1, 2, 3, for example, and 4, 5, 6, our function would take us from our domain to our range. Right? So the blue line, that is going to be my function. Now, what if instead I wanted to go from my range to my domain? So I still have my range, I still have my domain, right? So I still have my range, I still have my domain, it's still 4, 5, 6. My range is still 1, 2, 3, but instead I want to go in the opposite direction. I want to know what can take me from my range back to my domain, and what's going to take me from my range back to my domain is going to be the opposite of what took me to from my domain to my range. So my function took me from my domain to my range. And what's going to take me back from my range to my domain is known as the inverse function. So it's like I'm undoing what I did to get to the range, and I want to move back now to where I started from. This is known as the inverse function. Now, how do we find what is the inverse function? Well, we're going to follow a couple of steps, and that's going to help us be able to indicate what is our inverse function. But before I go forward, I just want to say, remember, our function was written as f of x. If we are talking about our inverse function, it's going to look a little bit different. It's going to look like this: f -1 on the top to the power of -1 of x, and this means f inverse of x. So we say it as f inverse of x. That is the reverse of my function f of x. Okay, so anytime you see inverse function, you're thinking of f inverse of x. And just regular function is just going to be f of x. I'm going to put in that notation on the top under inverse functions, and then we are going to look at the 3 steps that are going to help us find our inverse function. So these are going to be our 3 steps. Step 1, we're going to replace f of x on the left-hand side with x, and then on the right-hand side, we're going to replace that x with y. Our second step is we're going to make y the subject of the equation, and what we mean by making the subject of the equation means that y is on one side and everything else is on the other side. And then once we've done that, our third step is to replace y with f inverse of x. So let's look at an example, which is going to be the best way to understand these steps. So we're going to start with something relatively easy. Let's say that f of x is equal to x minus 7, and we want to find the inverse function. So we want to find f inverse of x. So we're going to follow our steps. Step 1 is on the left-hand side, which is here. We're going to replace f of x with x. So this becomes x. And on the right-hand side, we're going to replace x with y. So this becomes y minus 7. Okay, so we've done step 1. Step 2 means make y the subject of our equation. So I want y on one side alone, so the best thing to do would be to add 7 to both sides. On the left hand side I get x plus 7. On my right hand side I get y minus 7 plus 7. Plus 7 is going to be 0, so that's y plus 0, and anything plus 0 is itself. So I get y is equal to x plus 7. So I have made y the subject because y is on one side and everything else is on the other side. And now all I'm going to do is replace y with f inverse of x. So f inverse of x is equal to x plus 7. Right, because x plus 7 is equal to y. So if I replace y, I get f inverse of x is equal to x plus 7. Right, so those are my steps to finding an inverse function or f inverse of x. Let's look at another example. So let's say that f of x was equal to 2x plus 5, and we wanted to find the inverse function, f inverse of x. The first thing we do is on the left hand side we replace f of x with x, and on the right hand side we replace x with y. So this is 2y plus 5. Then we make y the subject. So I'm going to take away 5 from both sides first. So on the left I now have x minus 5. On my right hand side I have 2y plus 5 minus 5 gives me 0. So 2y plus 0 is simply just 2y. And I need to have y by itself. Currently I have 2 times y. So to get rid of that 2 in the front of y, I have to divide by 2 on both sides. So that's x minus 5 divided by 2. And 2y divided by 2. My 2's will cancel, giving me x minus 5 over 2 is equal to y. And then my last step is I replace y with f inverse of x. So I get x minus 5 over 2 is equal to f inverse of x, or f inverse of x, as in you can write it f inverse of x is equal to x minus 5 over 2. Okay, so that was simple enough. Let's look at a more complex example. So in this case, my f of x is equal to x squared minus 7. So again, I'm going to follow my steps. First step is I replace f of x on the left hand side with x, and I replace x on the right hand side with y. So this becomes y squared minus 7. And now I have to make y the subject. So I'm going to add 7 to both sides. I get x plus 7 is equal to y squared minus 7 plus 7 is going to be 0, and y squared plus 0 is simply y squared. And I want to find for y by itself. So whenever I have something squared and I just want to find for that value alone, I take the square root. So on the left hand side I get square root of x plus 7 is equal to the square root of y squared, and the square root of y squared is y, so square root of x plus 7 is equal to y. And now my final step is to replace y with f inverse of x. So f inverse of x is equal to the square root of x plus 7, or you can write it like f inverse of x is equal to square root of x plus 7. Let's look at another example. So now I have f of x is equal to 4x plus 6 all over 5. And again, all I'm going to do is follow my 3 steps in order to find the inverse. So on my left-hand side, I replace f of x with x. On my right-hand side, I replace x with y. So this becomes 4y plus 6 divided by 5. And now I need to make y the subject, which is y on one side and everything else on the other side. Now, because I have something that is a fraction on my right-hand side, I always want to get rid of the fraction, or basically get rid of the denominator. So since 5 is in the denominator, I'm going to multiply both sides by 5. So 5 by x will be 5x. Right, and then I have 4y plus 6 over 5 multiplied by 5. Or sometimes you'll put a dot so that you don't get confused with what's x and what's multiplication. So I'm multiplying by 5, or 5 over 1. So basically, these 5's will cancel, and what I'm left with is 5x is equal to 4y plus 6. So now I'm going to take 6 from both sides. And on my left-hand side, I will have 5x minus 6. On my right-hand side, I will have 4y minus 6 plus 6 is 0. So that's 4y plus 0. And anything plus 0 is just itself. So that's 4y on my right-hand side. And on my right-hand side, I have 4 times y. But I just want to have y by itself, so now I'm going to divide by 4 on both sides. So that's 5x minus 6 over 4 is equal to 4y divided by 4. My 4's will cancel on my right-hand side, so I have y is equal to 5x minus 6 over 4. And my final step will be to replace y with f inverse of x. So I get f inverse of x is equal to 5x minus 6 over 4. Let's look at one of the inverse questions that I think is probably the most challenging. Alright, so let's look at that example now. So we are given that f of x is equal to x plus 1 divided by x minus 2. So again, all we're going to do is follow our rules. This one is going to take a little bit longer, but we're just going to follow the rules and we will arrive at the designated response. So first thing is, on the left hand side, I'm going to replace my f of x with x. And then on my right hand side, wherever I see x, I'm going to replace with y. So I now have y plus 1 divided by y minus 2. Now I have a fraction in my on my right hand side, and just like we did before in the previous example, we would have gotten rid of our denominator, and in order to do that, we would multiply each side by the denominator. So on my left hand side, I will now have x times y minus 2. And then on the right hand side, I have y plus 1 over y minus 2 multiplied by y minus 2. And again, the reason that I am multiplying by the denominator is so that I don't end up with a fraction. I get rid of that fraction essentially, and then I'll work around my question. I don't want to have my y's that I'm trying to put on one side. I want them to be isolated, and I would prefer if they are not both in the denominator. So I multiply both sides by my denominator, which is y minus 2. and these cancel with each other, leaving me with x times y minus 2 is equal to y plus 1. Okay, so now I don't have that y minus 2 in my denominator. On my left hand side though, I have x multiplied by the entire value of y minus 2. And what I have to do in order to multiply that out is first distribute x multiplied by my first term, which is y, and then x multiplied by my second term, which is negative 2. So on my left hand side, I'm now going to have x times y is xy. X times negative 2 becomes negative 2 times x. Alright, so that's my left hand side. My right hand side remains as y plus 1. Again, remember what we're trying to do. We're working on step 2, which is to make y the subject of the equation. That means I need all my y's on one side, and I need everything else on the other side. Okay, so what are my terms with y in it? This one has a y in it, and this one has a y in it. Okay, so therefore, I am going to start first by adding 2x to the left hand side, because I want to put all my y's on the left hand side. Right? It's up to you. You can put it on the right, you can put it on the left. I want to put it on the left. So anything that is not involving a y on my left hand side, I need to get rid of. The only thing that doesn't involve a y on my left hand side is that negative 2x. So in order to get rid of negative 2x, I'm going to add 2x to both sides. Okay, so on my right hand side, I now have xy minus 2x plus 2x is going to be 0. So xy plus 0 is 0. Is xy, sorry. Right? So I'm getting rid of that negative 2x by adding 2x. On my right hand side, I now have 2x or y plus 1 plus 2x. Right? I'm just adding 2x there. Now, I want all my y's on my left side. So everything that's y on my right hand side, I need to get rid of. So there's a y here on my right hand side, and this is positive y. So to get rid of that y, I'm going to take y from both sides. So on my left hand side, I now have xy minus y. On my right hand side, I have y minus y is 0. 0 plus 1 is 1, so that's 1 plus 2x on my right hand side. So now I have y's on the left and other things on the right. But my first term has an x in it. So I need to make sure that I only have y's on my left hand side. But in my first term, I have a y that's common. And in my second term, I also have a y. So what I'm going to do is factorize or pull out a y. So I'm going to pull out a y. So if I pull out a y from the first term, what's remaining? So if I replace or pull out this y in the first term, what's remaining is x. And if I pull out y out of the second term, what's remaining is negative 1. And it's true, because if I were to multiply this back out, y times x will give me xy, and y times negative 1 will give me negative y. So essentially what I've done is pulled out the y, and I now have y times x minus 1 is equal to 1 plus 2x. And to get y by itself on the left hand side, I'm going to divide both sides by x minus 1. And that means that this will cancel on my left-hand side, giving me that y is equal to 1 plus 2x divided by x minus 1. And then my final step is to replace y with f inverse of x. So I now have f inverse of x is equal to 1 plus 2x divided by x minus 1. Now, these types of questions, finding the inverse, where you have x in your numerator and your denominator, it's difficult. It really is. It's the most kind of difficult in questions that you get regarding inverse functions. So we're going to do a couple more of those so that you pretty much get the hang of it. So let's look at another example. And again, all we're doing is following the steps with respect to finding an inverse function. So f of x is equal to 2x minus 1 over 5x plus 3. We need to find the inverse. So the first thing is on the left-hand side, we're going to replace f of x with x. And on the right-hand side, anytime we see an x, we're going to replace it with y. So we get 2y minus 1 divided by 5y plus 3. Now on the right-hand side, we have a fraction. And in our denominator, we have a term with y that's in our denominator. So essentially, we want to get rid of that denominator or not have a fraction currently on that side. So what we're going to do is multiply both sides by that denominator, which is 5y plus 3. So I have x multiplied by 5y plus 3 is equal to 2y minus 1 over 5y plus 3 multiplied by 5y plus 3. And again, the reason I'm multiplying by the denominator is so that they will cancel on my right-hand side. So on my left-hand side, I'm left with x times 5y plus 3. And on my right-hand side, I have 2y minus 1. Now, on my left-hand side, I'm going to distribute, or I'm going to multiply by that x. And I have to multiply by my first term, and I also have to multiply by my second term. So, x multiplied by 5y is 5xy, and x multiplied by 3 is 3x. My right-hand side remains as 2y minus 1. Now, I want to put everything that involves a y on the left-hand side and everything that doesn't involve a y on the right-hand side. So I'm going to take away 3x from both sides because I have 3x on my left-hand side and I don't want anything that doesn't involve y on my left-hand side. So I now have 5xy plus 3x minus 3x is going to be 0. So that's 5xy plus 0 is simply 5xy. That's equal to 2y minus 1 minus 3x. Right? Because I have to take 3x from both sides. Then I have a y term that's on my right, and I want to have everything that has a y attached to it on my left-hand side. So therefore, I'm going to take 2y from both sides. So on my left-hand side, I now have 5xy minus 2y. On my right-hand side, I have 2y minus 2y will give me 0. And then I have 0 minus 1 minus 3x will be negative 1 minus 3x. Now both these terms on my left hand side have a y that's attached to it. So what I'm going to do again is pull out the y And when I pull out the y, my first term, what will be remaining if I take out the y? Just 5x. And then my second term, if I take out the y, what will remaining? What will be remaining? Minus 2. So I put in minus 2. And then on my left-hand side, I have negative 1. Sorry, my right-hand side, I have negative 1 minus 3x. So now I have y times some value, and the value is 5x minus 2. I want to have y by itself. So what I can do here is divide both sides by 5x minus 2, so I can just have y alone on my left-hand side. So I'm going to divide by 5x minus 2, and then here I'm going to also divide by 5x minus 2. These will cancel with each other, giving me y is equal to negative 1 minus 3x, all divided by 5x minus 2. And my last step, right, so I have y is equal to negative 1 minus 3x over 5x minus 2. And my last step is to replace replace y with f inverse of x. So I'm going to take off y and replace that with f inverse of x. So the inverse function of 2x minus 1 divided by 5x plus 3 is negative 1 minus 3x divided by 5x minus 2. Okay, let's look at another example like this. So again, these are the most type of difficult inverse questions that you see, so I really want to get you accustomed with it. F of x is equal to 7 minus 2x divided by 6 minus x. So the first step, again, is to replace f of x on the left-hand side with x. Done. Then on my right-hand side, anytime I see x, I replace with y. So I have 7 minus 2y divided by 6 minus y. So on my right-hand side, once again, I have a fraction. There's a y variable that's in my denominator. So to get rid of that denominator, I'm going to multiply both sides by that denominator, because whatever I do to one side, I must always do to the next side. So I'm going to multiply both sides by 6 minus y, which is my denominator. So I get x times 6 minus y is equal to 7 minus 2y over 6 minus y multiplied by 6 minus y. This is going to cancel with this, leaving me with x times 6 minus y is equal to 7 minus 2y. Next, I want to expand what's on my left-hand side. So I'm going to multiply x by this first term. I also have to multiply x by this second term. So x times 6 will be 6x, and x times negative y will be negative xy. Then on my right-hand side, I still have 7 minus 2y. Now, I remember what I'm doing. I'm on step number 2. I would like to make y the subject of the equation. So everything that involves a y, I want on my left-hand side. Everything that doesn't have a y, I want it on my right-hand side, or I want to get rid of it. So when I look at my left-hand side, there's that 6x that's glaring at me. I want to get rid of it, so I'm going to take away 6x from both sides. So on my left-hand side, I have 6x minus 6x, which is 0. 0 minus xy is minus xy. On my right-hand side, I now have 7 minus 2y minus 6x. Then I have a y term that's on my right hand side. That's this term here. I want everything that's with a y on my left hand side. So in order to get rid of that minus 2y, I'm going to add 2y to both sides. Okay, so now I have negative xy plus 2y is equal to 7. Minus 2y plus 2y will be 0. And 0 minus 6x, that's minus 6x. Then on my right hand side, on my left hand side now, I have two terms. They both have y in it. So y is in common. I'm going to pull out the y. And if I pull out the y, what remains from the first term will be negative x. So I put in negative x. And what remains from the second term will be plus 2. So I'm going to put in plus 2. And that's equal to 7 minus 6x. So now I have y times some value is equal to 7 minus 6x. And I want y alone on one side. That's making y the subject of my equation. I just want y on the left hand side. Everything else I want it on the next side. So what I can do now is divide by x minus x plus 2 on both sides. Okay, so that top numerator is going to cancel with the denominator, giving me y is equal to 7 minus 6x divided by negative x plus 2. So I have essentially made y the subject of my equation, and up next, the last step that I have to do is replace y with f inverse of x. So I'm going to take away y and replace it with f inverse of x. So the inverse function of 7 minus 2x divided by 6 minus x is 7 minus 6x divided by minus x plus 2. Okay, so we've kind of covered most of the difficult questions that you can get when it comes to inverse functions. So now I'm going to kind of put them all together, and let's just do some practice problems so that you become more familiarized with inverse functions, which we are going to explore again 2 lessons from now. So again, when you're doing inverse functions, really all you need to remember are those 3 steps. The second step takes the longest, that is making y the subject of the equation, and then once you've done that, you replace it with f inverse of x, and then everything is great. So let's look at some further examples or practice problems. So the first problem is you're given that f of x is equal to the square root of x minus 3. And of course we have to find f inverse of x, or the inverse function. So we are going to start with step 1, which is replace f of x on the left hand side with x. And on the right hand side we're going to replace x with y. So this becomes y minus 3. Then step 2 means we have to make y the subject of the equation, which means that we need y by itself on one side. Now currently when I look at my question, y is underneath that square root sign. So the easiest way to be able to access y will be to get rid of that square root sign. And the only way that we can get rid of a square root sign is by squaring both sides. So my left hand side becomes x squared, and my right hand side becomes the square root of y minus 3 squared. right? When you square a square root, it removes the square root. So you get x squared is equal to y minus 3. And you want to solve for y, so you want y on one side, everything else on the next side. So I'm going to add 3 to both sides. So on my left-hand side, I'm going to get x squared plus 3. And on my right-hand side, I'm going to get y minus 3 plus 3. Minus 3 plus 3 is 0, so that's y plus 0 is simply y. So now I have y on one side, and I have everything else on the other side. So I've effectively made y the subject of my equation. And my last step is to replace y with f inverse of x. So I get f inverse of x is equal to x squared plus 3. Our next problem is the square root of 3x minus 4 all over 5. So again, we replace f of x on the left-hand side with x, and on our right-hand side, we replace x with y, so we have 3y minus 4 over 5. Anytime we have a fraction on our right-hand side, we always want to get rid of that denominator. So in order to do that, we're going to multiply both sides by the denominator, which is 5. So 5 times x becomes 5x on my left-hand side, and then I get the square root of 3y minus 4 divided by 5 multiplied by 5. So that means that my 5's are going to cancel, and I'm just going to be left with 3y minus 4, square root of 3y minus 4. So remember, I'm trying to make y the subject of the equation, and my y is currently under that square root sign. So I needed to get rid of that square root sign, and the only way I can do that is by squaring both sides. So I'm going to find 5x squared and 3y, square root of 3y minus 4 squared. 5x squared, rules of exponents, means that you have to square each term. So that is 5 squared, which is 25, times x to be squared, which is x squared. And then on my right-hand side, a square root squared gets rid of the square root sign. So that we're left with 3y minus 4. So that's why we square it, because when we square a square root, that goes away. So now on my left-hand side, I have 25x squared is equal to 3y minus 4. And I want to find y by itself. So I am going to add 4 to both sides to get rid of this 4 on my right-hand side. So when I add 4 to both sides, I get 25x squared plus 4 is equal to 3y minus 4 plus 4 is 0. So 3y plus 0 is simply 3y. And I want y by itself. Right now I have 3 times y, so I need to divide both sides by 3. So that is 25x squared plus 4, all divided by 3, is equal to 3y divided by 3, and my 3's cancel. So what I'm left with is y is equal to 25x squared plus 4 divided by 3. So I've effectively made y my subject of my equation, and then my last step is to replace y with f inverse of x. So I get f inverse of x is equal to 25x squared plus 4 divided by 3. Okay. Final question. Our final example of problem is the most challenging question that I could come up with. We have f of x is equal to the square root of x squared plus 1 divided by x. And again, all we're doing is following the rules of inverse functions. So anywhere you see f of x on the left-hand side, replace with x. Anywhere you see x on the right-hand side, replace with y. So you have square root of y squared plus 1 divided by y. Now on the right-hand side, you have a fraction. We don't like having fractions, so we always multiply by the denominator. So we're going to multiply both sides by y. So we get x times y is equal to the square root of y squared plus 1 divided by y multiplied by y. The reason why we multiplied by y is so that this would cancel and we would just be left with square root of y squared plus 1. Now we're on the second step. We're making y the subject of the equation, which means y, all the terms with y need to be on one side, everything else needs to be on the next side. Now currently I have a term with y that's underneath my square root and it's on my right hand side. So basically I need to get rid of that square root. And the only way I can get rid of that square root is by squaring both sides. So I get xy squared is equal to the square root of y squared plus 1 all squared. And then remember, the reason why I'm squaring is because when I square a square root, it gets rid of the sign. It gets rid of the square root sign. So on my left hand side I have xy squared. Rules of exponents tells me that it's x squared times y squared. And again, those rules of exponents would have been covered in the previous course, which is Foundational Mathematics for Secondary School, the beginner level. So we would have covered exponents in that course. So now on my left hand side, squaring a square root gets rid of that sign. I'm left with y squared plus 1. And now I want to put everything that involves y on one side. So I have a y term on my left already. I want to put the y term that's on the right hand side, which is this one, on that side. So I have x squared y squared is equal to y squared plus 1. Right? So I want to not have that y term on my right hand side, so I'm going to take it away. If I take away y squared from both sides, on my left hand side I'm now going to have x squared y squared minus y squared is equal to y squared minus y squared is 0. 0 plus 1 is 1. So now I have two terms that involve y on my left hand side. I'm going to pull out y squared because y squared is common in my first term. I have a y squared here, and y squared is also in my second term. So I'm going to pull out y squared. And if I take out y squared out of the first term, all I'm left with is x squared. So I put x squared in my parentheses. Then if I take out y squared from my second term, all I'm left with is minus 1. So this becomes minus 1 equal to 1. So I just want anything with y on my left hand side, so I'm going to divide both sides by x squared minus 1. Right? That means that this will cancel on my left hand side. So what I'm left with is y squared is equal to 1 over x squared minus 1. But remember, I need to make y the subject of the equation. Not y squared, not y cubed, not y anything. I just need y by itself to be the subject. So how do I move from y squared to y? Well, if I find the square root of y squared, it's going to be y. Right? It's the same thing. If I have 4 squared and I find the square root of 4 squared, I end up with 4. So if I have y squared and I want to find y by itself, I find the square root of both sides. So I get the square root of y squared is equal to the square root. Let me put it in another color for the moment. I get the square root of y squared is equal to the square root of 1 divided by x squared minus 1. Or you can say, when you take square root, you take the square root of each of top and bottom. So that will be the square root of 1 divided by the square root of x squared minus 1. Right? So the square root of y squared is going to be, remember we're taking the square, right? So the square root of y squared is going to be y. And then on my left hand side, running out of space. Right, on my right hand side, I'm going to have the square root of 1 over x squared minus 1. Okay, so again, what I did is on my left hand side I have y squared. My rules say I want to make y the subject of the equation. Just y by itself, not y squared, not y cubed, just y. So if I have y squared and I want to move from y squared to y, I have to find the square root. The square root of y squared will give me y, and then I find the square root of my right hand side, which is just the square root of 1 over x squared minus 1. And then my final step is to replace y, because I just put everything in terms of y, so I effectively finished the second step. So my final step is to replace y with f inverse of x. So I get f inverse of x is equal to the square root of 1 divided by x squared minus 1. So I would have saved the most challenging question for the end of this lesson. So just to recap, in this lesson, we talked about inverse functions. Basically, when we did functions in the beginning, it moved us from our domain to our range. If we want to move back from our range to our domain, we're going to need to use the inverse function. And in order to find the inverse function, basically we follow these 3 steps, which we've been doing for the last however long, and that is to replace f of x on the left hand side with x, replace x on the right hand side with y, then we make y the subject of the equation, and when we've done all of that, we just replace y with f inverse of x. So that's what we've been doing, and this brings us to the end of this lesson with inverse functions. Again, you can practice with the practice problems and solutions at the end of this video, the written practice problems and solutions, and make sure that you thoroughly know these 3 rules, because we're going to be going back again into inverse functions in the next 2 lessons. We're going to be combining what we would have learned in the next lesson with what we remember from inverse functions. So that brings us to the end of this lesson. This is Foundational Mathematics for Secondary School, Intermediate Level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log into our website from any place, at any time, and view past videos, practice problems, and solutions for your course. For more information on the services we offer, you can visit our website, that is www.limitlesslearningtt.com. And if you have any additional questions or concerns, you can always send us an email, and our email address is info@limitlesslearningtt.com.